let's jump into section 2.3. This is scatter plots and regression. And once again, if you don't think the class has been mathy enough, it's about ready to get a whole lot mathier. So we're going to start with scatter plots. And we're going to begin with this thing called a time series plot, because this is a scatter plot that most of you are familiar with. It's kind of an easy introduction to scatter plots. And so if you go through and you measure two things, maybe you measure time. Again, this is why this is called a time series plot. And then you measure one other variable. Let's say, for example, your weight in pounds. And so this is someone who had gone through and each month they weighed themselves and measured what their weight was in month 1, month 2, month 3, month 4, and maybe they're on a diet or an exercise regimen or something like this, right? So essentially what you're creating are these two linked data points, right? They're linked together. At month 0, the weight was 200 pounds. And essentially you're creating an ordered pair, 0, 200, right? This would be the X coordinate and this would be the Y coordinate. And we can graph those on an axis. So we're going to take the X coordinate, which is the time, and we're going to take the Y coordinate, which is the weight, and we're going to plot them on a graph. Pretty easy, okay? And if we do this for all 6 values, we get something called a scatter plot, or in this case, a time series plot, because time is involved, okay? One thing to notice about this is we're going to show you the top graph and the bottom graph. Once again, just drawing your attention to the fact of acknowledging the scaling of the graph. If you take a look at this, you'll notice that the first graph goes from 0 to 250. The second graph goes from 185 to 205. So if you wanted to minimize the weight loss, you would show the top graph. It's like, oh, you barely lost any weight. Look at that. It's like a flat line. There's hardly any difference. On the other hand, if you were the manufacturing of a super diet pill, you would want to use the second graph. Exact same data, but the second graph is scaled differently to accentuate the difference between the initial weight and the final weight, right? It looks like it's going down more dramatically than in the top graph. So just always be aware of that scaling, okay? Important concept. So now what if we break away from the time series graph and just do 2 variables, okay? So here's an example of that. Let's say we go out and we go to a state and we measure the elevation and the temperature of different cities in that state. So here's the elevation in feet. So here's a city that's at 7,000 feet above sea level, 4,000 feet above sea level, 6,000 feet above sea level. And here is the temperature of those cities on the same day. So you travel to maybe Colorado, and on June 23rd, you travel to these 1, 2, 3, 4, 5, 6, 7 cities. You measure the elevation, you measure the temperature, and you collect this data and put it in a table, okay? So now what we want to do is we want to graph this, and we want to know, is there a relationship? Is there a correlation between the elevation and the temperature on that day? And that's really what we're getting at. And then if we do establish a correlation, could we make a prediction about another elevation that maybe isn't on our table? So we want to sort of create this model. So that's what we're doing. So you would take your data and you'd plug it into a Google Sheet, and it looks something like this. Boop, here's my data in a Google Sheet. And then you're going to go to Insert Chart, and you're going to select a scatter plot. And we're going to do this in a little bit. This is the activity that we're going to show you. And then you go in and you kind of do the standard things that we've talked about before, right? Like you go in and you give the chart a nice title. You put labels on the axes. Maybe you put data labels in there, and of course, a background color. Don't forget that. But here are some new things: data labels, trend lines, use equation, and R squared. These are new things that we haven't seen before in our graphs. And we're going to explore that today. That's what we're going to look at. And we're going to get all kinds of mathy as we learn about that. Okay, so this is essentially what the graph would look like. If you go in, and we'll show you how to do this, this is a picture of the graph. So here are all of your data points, right? Remember, elevation is on the x-axis and temperature is on the y-axis, temperature in degrees Fahrenheit, okay? And each one of these is a data point from our experiment, our data collection. And you'll notice that there's a red line that goes through this data. This line is called the line of best fit. It is the line that best fits the data that we're going to use as a model, okay? And you may notice here is the equation of the line. What we're going to do is we're going to show you how to calculate that equation of the line by hand first, and then we'll show you how to generate it automatically in Google Sheets, okay? But let's get into how do you calculate this line? How do we find the equation of this red line? And if you remember back in algebra, you probably remember y equals mx plus b, right? And m was something called the slope of the line, and b was the y-intercept. So every line has a first name and a last name. Its first name is the slope, the last name is the y-intercept. That's how we differentiate one line from another line. We look at their slope and we look at their y-intercept. So these are two things that we're trying to find out about the line that best fits this data, okay? And that process of finding this line of best fit is called regression analysis. And that's what we're going to do. We're going to figure out how do we find this line of best fit. And visually, I can show you, it looks something like this. So here I have some plotted points. We're in Desmos, so you can see I've got these points all in here, right? So I got 5 points in here, and I would like to draw a line that best fits those points. So I could create a line that goes through. Is that the best line? Is that the line that fits the data the best? What about that line? Does that fit the data really well? Or this line? Or this line? Or this line? How do I find which line is the best fit? Because I can wiggle this line all over the place, right? How do I find the line of best fit? And so what we're going to do, I'm going to accentuate some of these. Bloop, bloop, bloop. Let's put these points up like this. There we go. Okay, and I'm going to grab this image, and I'm going to show you how we're going to calculate this. Okay, so I need to go back to this, and we're going to scroll down past all this, and we'll paste that there. So this is what we're going to do conceptually, okay? So we've got this line, and what we're going to do is we're going to find the distance each point is from the line, okay? We're going to find this distance, and this distance is going to be sort of like a subtraction, okay? So we're going to find out what this distance is. And then what we're going to do is we're going to make a square out of that distance. And we'll call this A1, okay? Area of the first square. Then we'll find the distance from the second point up to the line, and we'll make an area out of that. We'll call that A2. Then we'll find this distance, and we'll make another square. We'll call that A3. Here is A4. And here is A5. Okay? So we're going to make squares out of all these distances, and then we're going to add them up. You're going to add up all these areas. So you're going to say A1 plus A2 plus A3 plus A4 plus A5. This is the sum of squares. Get it? You're like, the words make sense. You're summing squares. Okay, so we're going to find the distance first, and then we're going to square that distance, and then we're going to add them all up. Now, the line of best fit, the line of best fit has a sum that is a minimum. So if you wiggle this line around, the areas of those squares will change. And the line of best fit is the line that gives you the minimum sum of squares. So when these areas are minimized, when you get the smallest area, that is the equation for your line of best fit. Okay, so remember these steps. Step number 1, find this distance. Step number 2, square it to get the area. Step number 3, add them all up. Okay. Remember those 3 steps because we're going to get mathy and do some math to do those 3 steps. Okay. So this conceptually is what we're doing. Now let's do it mathematically. And so I got to jump into this and we got to go way back up here. Here we are. Regression analysis. And this is what we're going to do. So we went out and we sampled 9 12-ounce beers and we measured 2 things. Number 1, the alcohol content, and number 2, the calories. And the question is there a relationship between the alcohol content and the number of calories of a beer? As your alcohol content goes up, does the calorie level go up? As the alcohol content goes down, does the calorie level go down? Let's figure out if there's a correlation between these 2. So what we're going to do is we're going to plot all these points. So we create the scatter plot. And now what we'd like to do is run a line of best fit through this data set. Okay. Sound easy? Here's how we do it. Oh boy. And we're going to do this in a spreadsheet. This is your 2.3 assignment. Okay. So you want to pay attention to this. Here we go. Let me explain this. Number 1, the blue column, the first blue column is your data from the table. So if you go up to this table right here and look at alcohol content, there is your alcohol content. These are the 9 data points. Okay. What you have to do is you have to find the mean of those 9 points. Okay. That's the average. Then you find something called the residual, which is the difference from the mean. So you take 4.7. Here is 4.7. And you're going to say, how far away from the mean is 4.7? The mean is 5.5. The data point is 4.7. How far away from 4.7 is 5.5? In other words, you're finding step number 1. Maybe this is your 5.5. And this, well, actually your 5.5 would be this point here. So this would be 5.5. And this point here is 4.7. How far away are they, right? You're finding this length. That is called the residual. And so you're going to just do a subtraction. Let's get back down to this. So you're going to subtract these 2, and you're going to find that 4.7 is 0.8167 below the mean because it's negative, right? The next point is 6.70. That's 1.1 above the mean. So you're finding the difference from the mean. You're finding the difference between the point and the line of best fit. Then you're going to create a square out of that difference, which means, yes, you literally square that difference. You're going to raise it to the 2nd power. So each one of these differences, each one of these residuals are squared. And then you're going to add them all up. This is called the sum of the squares of the x coordinates. Okay. You're going to do the exact same thing for the y coordinates. So moving over to the y coordinates, here is the data from our table, and we find the mean of the y coordinates. These were the calories of the 9 different beers that we had. So the average calorie count was 170. Then you're going to go back to each data point and you're going to say how far away from the mean was 163. And 163 is 7.222 below the mean. 215 is 44.7 above the mean. 222 is 51 above the mean. You're finding the difference, the distance between the mean and each point. Then you're going to make the square. You're going to square it. Again, literally raising it to the 2nd power. Then you're going to add these all up. And this is the sum of the squares of all the y values. The last thing we need to find is something called the residual product. So if you take a look at what the residual product is talking about, you're going to take the x difference, the residual of the x's, and you're going to multiply it by the residual of the y's. So you're going to take this column, this value, you're going to multiply it by this value, and that will give you this number. You're going to do that for each row. So this value, times this value gives you that. And then you're going to add these all up. And that is the sum of the squares of the products of the residuals. So we've essentially given you 5 new pieces of data, 5 new pieces of data. We've given you the mean of the x's, the mean of the y's, right? That wasn't too bad. And then we gave you the sum of the squares of the x's, the sum of the squares of the y's, and the sum of the squares of the products of these residuals. So these 5 pieces of information are going to be used to find the slope and the y-intercept of the line. How do we use them to find that? The slope of the line, the slope of our line of best fit is SSXY divided by SSX. So you take this value, 327.6667, and you divide it by 12.4498. Whatever this value is, that's the slope of your line, the line of best fit. And here is that calculation. So the line of best fit has a slope of 26.3. So if we go back up to this idea right here, the line of best fit that best fits our data has a slope of 26.3. That's the slope of the line of best fit. Now we need to find the y-intercept. And so you can do a little algebra. This y bar means the mean of y, the average of y. And remember, we had that right up here, right? This is the average of y. Let me get rid of these. This is the, this is the average of the y's, and this is the average of the x's. So we're going to use those 2 pieces of information. We're going to plug them in here along with the slope that we just calculated, and we're going to calculate the y-intercept. Is it mathy enough for you yet? Have we gotten into the deep water of mathematics? Yeah, a little bit. We're doing some algebra here. This is your y-intercept. So when we take our slope and we take our y-intercept and we put them all together, this is the equation of our line of best fit. This is the line that best fits our 9 data points, okay? Great. Now we can use this line of best fit, this model, to make predictions about other beers that we sample. So if we go out and we grab a beer off the shelf and we notice that it has an alcohol content of 6.5, we could plug that into our equation. We could plug it into our model and make the prediction that according to our model, that beer should have about 196 calories based on the model that we created from the 9 beers that we sampled, okay? And so this is an important activity to be able to do. And so what we're going to do now is I'm going to show you how to do this in the Google Sheet, okay? So that's all we're going to talk about is getting to this equation, this linear equation. And now let's show you how to do it in the Google Sheet. So here's the Google Sheet for 2.3. And you'll notice the instructions are all given to you step by step right here. Calculate the mean, subtract the mean from each x value, find the difference from the mean, find the difference from the mean here, and then find the sum of the differences, and then repeat it for the y values. Then here's how you find the slopes and the y-intercept, okay? So let's show you how this is done in Google Sheet. So I'm going to open up a Google Sheet. Here we are. And here's the data. Here's one data set, and here's another data set, okay? And what we're going to do is I'm going to walk you through doing these exact same calculations in Google Sheets. Now, remember, we're recording this. So after we're done going through this, if I went through it a little bit fast and you want to go back and review something, go back and watch the recording, and you'll be able to see these step by step, okay? So here we go. Let's start with the x values. So here are the raw x values, right? These are the data that I went out and collected. We need to find the mean, the average of these. So the mean is equals average, and I'm going to add these all up or select those cells. And so there's the average. Let me zoom in just a little bit for you. Here is the average of my x values. There's the average, okay? And now what I want to do is I want to, in this cell, notice the header, take the X value and subtract the mean. So I'm going to say equals, that tells Google Sheets something mathy is going to happen. The X value minus the mean. And it gives me a value. There it is. So this tells me that 43.3 is 6.4 above the mean, right? So think of the mean being that line, and this data point is 6.4 units above that line, okay? Now, I don't want to type this formula for every single cell. So I'm going to click on the cell. I'm going to click on my calculation that I just did. And notice that you get that square in the lower right corner. I'm going to click on that square and I'm going to drag it down to fill down. And when I fill down, something bad happens. You can see that I get like these values in here. Things are messed up. And the reason something bad happens is because when you do the fill down, it shifts all of your values down row by row by row. So this is what I mean. If you take a look at this, you can see that the first calculation is 43, the orange box, divided by the purple box, or minus the purple box, right? If I go to the next cell, you can see that the orange rectangle moved down one row, but so did the purple rectangle. It moved down one row. And if I go to the next item, the orange rectangle moved down one row and the purple rectangle moved down one row. And I want the orange rectangle to move row to row to row to row, but I don't want the purple one to move. I want the purple rectangle to stay on B13. I don't want it to move. So in order to do this in Google Sheets, you freeze the cell. So on the purple cell, I'm going to put a $ in front of the column. That freezes column B. And I'm going to put a $ in front of the row. That will freeze row 13. So when I do the fill down, B2, the orange rectangle, will switch from B2 to B3 to B4 to B5. But the purple rectangle, B13, will not change. It will stay B13 as I fill this down. Okay, so there's my formula. And now, once again, I'm going to click on it. I'm going to click on the cell. I get the square in the lower right corner. I'm going to click on that square and I'm going to drag it down. And now I get nice numbers. Check that out. And so again, as I click on this cell here, you can see that is taking the data point value 37.4 and it's subtracting the mean from it. And you can see that 37.4 is 0.5363 blah, blah, blah above the mean. Okay. Remember what we're finding here. This is the distance between the point and the line. This is the residual. Now we're going to square that residual. So this is actually pretty easy. You're just going to raise it to the second power. This caret is Shift 6 on your keyboard. So if you're wondering how do you do exponents, Shift 6 will give you that caret. And so here is, let me get rid of this. There is 6.43 squared. And now again, I'm not going to do this for every single, I'm not going to hand type it in. I'm just going to click on the square and I'm going to drag down. And there is the square of each one of those rows. And now I'm going to add them up. I want the sum of the squares. So I'm going to say equals sum. I'm going to highlight these data. And there is the sum of the squares for my X coordinate. That's the sum of the squares. Okay, so here's the mean. And here is the sum of the squares of the residuals. Now we're going to do the exact same thing for the Y coordinates, and I'm going to do it much quicker. Okay, so here we go. Here's the mean. So average, we're going to average these values right here. There they are. Now we're going to take this data point and we're going to subtract the mean. We're going to find the difference from the mean. We're going to put the $ on to freeze that cell. We're going to fill it down. Then we're going to square that value, fill that down. And now we're going to find the sum of those squares. Boop, there you go. So here's the sum of the squares. So that's the exact same procedure for the Y coordinates. The last thing we need, the last thing is the sum of the product of the residuals. So again, look at the title, the header of the column. This is the mean, or X minus the means, which is this column here, and Y minus the mean, this column here. So we got to find the product of column C and column G. So we're just going to say equals, this cell times, which is shift 8, this cell. And there's the product. This is column C times column G. We're going to grab this and fill it down, and then we're going to add them all up. SUM of these values. Okay. Do we do that right? Equals sum of these values here. There we go. That looks better. Okay. So now that we have this, now that we have our mean of X and Y, we have SSX, we have SSY, and we have SSXY, we can do a calculation to find the slope of our line. So the slope, if you remember, is equal to SSXY divided by SSX. And so there's the slope of our line, negative 2.24. That's the slope of the line of best fit. We can find the y-intercept by using this formula. This is just a little algebra on y equals mx plus b. So we're going to say equals the mean of the y's, which is this coordinate 52.22, minus our slope times the x mean, or the mean of the x values. And there's our y-intercept, negative or 134.9. So for this data set, for this x and for this y, if we were to make a scatter plot, this would be the slope and the y-intercept of the line of best fit. So let's take a look at that. Here's the data. This is the exact same data, just in a more condensed format. I'm going to highlight it, and I'm going to go up to my toolbar, and I'm going to say Insert Chart. And we've done this before. We've done insert charts before. And so here is the scatter plot of that data. And so you can go into scatter chart. Here's the setup. So this is a scatter chart. We don't want a bar chart or a circle chart or a histogram. We want something called a scatter plot, which is right here. Okay. We could do a bubble chart that just takes the scatter plot and makes it a lot bigger. We don't really want a bubble chart. Let's go back to the scatter plot. So boop, there we go, scatter plot. Okay. And so here is all of our data. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 11 data points, and they are all graphed here on this. So let's go into customize, and under chart style, let's give it a background color. Oop, there we go. And maybe we could go into title and axes, and we could say X coordinate versus Y coordinate. Now that's about as good as a title as I could give it. So there's our title. Okay. And now we've got this data set. What we'd really like to do is put in a line, right? And if you take a look at our data set, our line of best fit should have a slope of negative 2.24 and a y-intercept of 134. So this is how we can create that line. And again, if you go back to what we talked about here in the reading, remember those things that we highlighted in yellow right here? When we talked about take your data, put it into Google Sheets, do a scatter plot, and then we want to look at these specific 3 things, right? This we've done. We did these things. Now we're going to talk about these 3 new items, okay? So here we go. We're going to go back to the chart. We're going to double click on it. We're going to bring up our chart editor. And remember, there's 2 tabs in the chart editor. There's the setup and the customize. Setup, customize, setup, customize. We're going to go to the customize tab. We've done the chart style with the background color. We've done the chart axes. And now we're going to go to series. All right. So under series, this is where you can go ahead and give the data points a different color if you wanted to. We'll stick with the blue. That seemed to work pretty good. And we could even change the shape of the markers. So if you wanted to change it to pentagons or squares or triangles, you could do that. You could increase the size to make them a little bit bigger. Well, I'm going to stick with the circles though. We'll do that. And now here is the new information. As you scroll down in series, there are 3 checkboxes. Now, the first one, error bars, we're not really going to use. The second one we've used before, data labels. So if we click data labels, boop, there they are. There are the labels on your data. And we don't really need data labels, so let's turn those off because they kind of get in the way a little bit in this particular case. But here is the checkbox that you really need to make sure you know where it is. Trend line. So go ahead and click trend line. Boop, and there it is. It automatically puts that line of best fit right into your graph. And I'm going to make this a red trend line. Maybe we'll thicken it up a little bit so you can see it better. We'll increase the opacity so it's in there like 100%. That's a nice, solid red trend line. This is the line of best fit. This is the line that has a slope of -2.4 and a y-intercept of 134, okay? And so this is great. There's my line of best fit. But let's take it one step further. As you go down to the series and you scroll down and you check the trend line, you get to change its color and change the thickness. But check this out, label. Right now, there's no label on this line. If you click the drop-down menu under label, you will see use equation. And when I click use equation, watch my title of the graph, okay? Watch where it says X coordinate versus Y coordinate. 3, 2, 1, boop. There's the equation of the line. We didn't have to go through all those steps of the table, right? Finding the difference from the mean, finding the square of the difference from the mean, adding them all up, dividing by this and that. You just click use equation and Google Sheets will give you the equation of that trend line. Look at -2.24, -2.24. 135, 134.9. So it does a little rounding, but that's okay. We didn't have to go through all of these steps to get at the slope and the y-intercept. We just had to click on the graph, throw our data into Google Sheets, go to series, scroll all the way down to trend line, and click use equation. How about that? Not bad, okay? If you don't want to put your data into Google Sheet, if you don't want to create this nice picture, we can do this exact same thing with a formula in Google Sheets. Now, I like seeing a picture of my data. I like seeing a picture of the line that goes through the data, the line of best fit. I like seeing this stuff because it helps me visualize what I'm working with, okay? But if you want to avoid doing all of this, let's say you're crunched for time and you don't have time to create the scatter plot, this is the equation you will use. And this equation is in the notes for class. If you go to chapter 2 and look at the Google Sheets, here's the equation. You type equals LINEST, line ST, LINEST, and then you do a parenthesis. Then you enter your Y data first, highlight your Y data, a comma, and then highlight your X data, and then put in an end parenthesis. So again, we're just dealing with the raw data here. We've done nothing else. We just got our raw data. We did equals LINEST. We highlighted the Y data, comma, we highlighted the X data. And then when we hit enter, it automatically gives us the slope and the y-intercept of the line of best fit without a graph, okay? So notice, they're exactly the same. 2.247, blah, 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 2.247, blah, 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 134.90, blah, 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 134.90, blah, blah, blah. Exact same values. And you didn't have to go through and do all of these steps. Now, make no mistake, we have to show you how this is done manually. We have to show you how these numbers are gotten. And probably by the time we were doing this with the Y coordinates and all this stuff over here, you're like, are we going to have to do this for every problem? Create this spreadsheet and find the mean and then the difference from the mean and then square the difference from the mean and then add them all up and divide and do all this? No, you do not have to do it. You have to do it once. You have to do it once for the Google Sheet assignment. But once you've built this one time, you now have an appreciation for the graph, using the scatter plot and the equation and the shortcut for Google Sheets, LINEST. This is an amazing equation that does all of this stuff extremely fast. Okay. And so there you go. And that's what we want to do. We want you to develop an appreciation for the power of the spreadsheet.